Now in this video we will go to take up one more problem. Figure shows a stepped shaft. It is subjected to a torque T2 which is equal to 900 Newton meter at the free end and a torque T1 which is 2300 Newton meter in the opposite direction at the junction of the two sizes. So that means you have the clockwise here and we have counterclockwise here. The material is steel with a shear modulus G is equal to 76 GPa. A. Calculate the maximum shear stress tau max in the shaft and the angle of twist at NC. And B. If the maximum shear stress in BC must be the same as that in AB. What is the required diameter of the segment BC? What is the resulting twist at the NC, which we need to find out. As we have given the figure, with one end is fixed and the other end is free, subjected to a twisting moment, which is T2 in the counterclockwise between the section B and C, having the diameter 45 of the length 510, which T2 of 900 Newton meter. And you have a clockwise twisting moment of T1, which is equal to 2300 Newton meter for a length of 760 at this junction between B and C, having diameter 58, having the length 760. So the torque on BC will be equal to minus 900 Newton meter, because by the convention we are taking counterclockwise direction as negative and clockwise as positive. And the torque on AB will be equal to minus 900 plus 2300 will be equal to 1400 plus. So you have the torque on 1400 Newton meter on the positive side between torque AB. Now we will try to analyze. G will be equal to 76 GPa, which is 76 into 10 to the power of 3 Newton per mm square. So diameter of the section AB will be equal to 58 mm and the diameter of the section BC will be equal to 45 mm and the length of AB is 760 mm and length of BC is 510 mm. And torque on BC will be equal to 900 Newton meter, which is 900 into 10 to the power of 3 Newton mm. And torque on AB will be equal to minus 900 plus 2300 will be equal to 1400 Newton meter, which will be equal to 14 into 10 to the power of 5 Newton mm in clockwise direction. So A, the maximum shear stress tau max and angle of twist at theta C we need to find out. So segment AB will be having the polar moment of inertia, which is JAB, will be equal to pi into d to the power of 4 by 32 on the section AB, which will be equal to pi into 58 to the power of 4 by 32. So on simplification, you will going to get it as 1.111 into 10 to the power of 6 mm to the power of 4. So polar section modulus ZAB will be equal to JAB by RAB, which will be equal to, substitute these values, 1.41111 into 10 to the power of 6 divided by 29, because 58 by 2, which will be 29. On simplification, you will going to get it as 38.31 into 10 to the power of 3 mm cube. Similarly, torque at segment AB, TAB, will be equal to 14 into 10 to the power of 5 Newton mm. So therefore, RAB will be equal to DAB by 2, which is equal to 58 by 2, which is equal to 29 mm. That was what I already told you. Similarly, the shear stress in the segment tau AB will be equal to TAB by ZAB, because T will be equal to, the general equation is ZP into tau. So substitute the values, that is 14 into 10 to the power of 5 divided by 38.31 into 10 to the power of 3. On simplification, you will going to get it as 36.544 Newton per mm square. Similarly, angle of twist at the segment AB, which is theta AB, will be equal to TAB into length of AB by G into JAB, which will be equal to 14 into 10 to the power of 5 into length of AB is 760 divided by G, which is 76 into 10 to the power of 3 into 1.1111 into 10 to the power of 6, which will be equal to 12.6 into 10 to the power of minus 3 radians, which is in clockwise direction. So similarly, segment BC will be having that polar moment of inertia of JBC will be equal to pi into d to the power of 4 by 32 for the section BC, which will be equal to pi into 45 to the power of 4 by 32. On simplification, you will going to get it as 402.578 into 10 to the power of 3 mm to the power of 4. Similarly, polar section modulus ZBC will be equal to JBC by RBC, which will be equal to 402.578 into 10 to the power of 3 divided by 22.5, because it is 45 by 2, which will be 22.5. So on simplification, you will going to get it as 17.892 into 10 to the power of 3 mm cube. So torque at the segment BC, which is TBC, will be equal to 9 into 10 to the power of 5 Newton mm. So shear stress at the segment BC, which is tau BC, will be equal to TBC by ZBC, which is equal to, substitute the value, 9 into 10 to the power of 5 by 17.892 into 10 to the power of 3, which will be equal to 50.3 Newton per mm square. Similarly, angle of twist on theta BC, which is BC, will be equal to TBC into length of BC by G into JBC. So substitute the values now, which is 9 into 10 to the power of 5 into 510 by G, which is 76 into 10 to the power of 3 into 402.578 into 10 to the power of 3, which will be equal to 15 into 10 to the power of minus 3 radians, which is in counterclockwise direction because it is positive value. So the maximum shear stress will be at the section BC, because where you have the least cross-sectional area. So tau or tau max will be equal to tau BC, which is equal to 50.3 Newton per mm square. So therefore, angle of twist theta C will be equal to theta AB minus theta BC, which is 12 into 10 to the power of minus 3 minus 15 into 10 to the power of minus 3. On simplification, you will going to get it as minus 2.4 into 10 to the power of minus 3, which will be equal to minus 2.4 into 10 to the power of minus 3 into 180 degree by pi, because you have to convert this radians into degrees, which will be equal to minus 0.14, that is equal to 0.14 degrees, because it is in the counterclockwise direction because the value is negative. So similarly, in the case B, if tau BC is equal to 36.544 Newton per mm square, that means it should be having the shear stress is same. So torque at the segment BC will be equal to TBC, which will be equal to pi d cube by 16 into tau BC, which will be d cube BC will be equal to TBC into 16 divided by pi into tau BC. So d cube will be equal to 16 into 9 into 10 to the power of 5 by pi into 36.544, which will be, on simplification, the diameters of the segment BC DBC will be equal to 50 mm. So similarly, we have the angle of twist now. The angle of twist of segment BC, which will be theta BC, will be equal to T into BC, that is T into L by G into J, which is of BC section. So substitute the values. So torque on BC, which will be equal to 9 into 10 to the power of 5 into length of BC is 510 divided by G, which is 76 into 10 to the power of 3 into JBC, which is pi into 50 to the power of 4 by 32, which will be equal to 9.843 into 10 to the power of minus 3 radians, which is again in counterclockwise direction. So angle of twist theta C will be equal to 12.6 into 10 to the power of minus 3 minus 9.843 into 10 to the power of minus 3, which will be 2.757 into 10 to the power of minus 3 radians, which will be equal to 2.757 into 10 to the power of minus 3 into 180 degree by pi, which is equal to 0.156 degrees. So when the tau max is equal to 50.3 Newton per mm square, which is theta C is 0.14 degrees, which is in counterclockwise direction. Similarly, the diameter of BC, which is 50, theta C will be equal to 0.156 degrees, which is in the clockwise. So this is how you will be able to analyze and solve this particular problem. Thank you.